Satellite signals are microwaves which travel in a straight path along the line of sight, and all geostationary satellites are located in an arc that goes across the sky. If we want to receive these satellites, we need to have an unobstructed view of this arc. You can conduct a preliminary survey at the site by facing south for locations north of the equator, or north for locations in the southern hemisphere. Here, we have a relatively clear and unobstructed view of the sky from the southeast to the southwest. Even at this site, however, there are limitations. Most large dishes are actually symmetrical prime focus parabolic antennas. The parabolic curve incorporated into the dish design has the property of reflecting all signals arriving along the antenna's axis of symmetry to a focus located to the front and center of the dish, hence the term prime focus. Check to ensure that the feed horn is centered over the dish. You can do this by taking 4 measurements at equidistant points from the feed horn to the rim. All of these measurements should be equal. Another measurement that will vary from antenna to antenna is the focal distance. That is, the distance from the center of the dish to the lip of the feed horn. This is specified in your antenna installation manual. The focal distance from dish center to feed horn opening is a function of the antenna diameter and the depth of the selected parabolic curve. If you need to calculate this distance on your own, run a string across the face of the antenna and measure the antenna's depth. That is the distance from the string to the face of the dish center. Focal distance can be calculated by plugging the dish depth and antenna diameter values into either of the following formulas. Once your system is up and running, fine-tune the focal length by moving the feed in and out in small increments while watching the readout of a signal strength meter or a spectrum analyzer. Another thing to check, put the inclinometer along the face of the feed horn and then across the back plate of the dish. These angles should be the same. Mini feed horns for prime focus antennas can be divided into 2 parts. One is a scalar ring plate, which can be adjusted up and down the throat of the feed horn to match the focal length to antenna diameter ratio of the dish. To determine the F to D ratio of the dish, simply divide the focal length by the antenna diameter. The waveguide of an adjustable feed horn is marked with a scale that indicates the various F to D ratio settings. The F to D for a deep dish is between 0.25 to 0.32. Medium depth dishes from 0.33 to 0.39, and shallow dishes from 0.4 to 0.45. Adjusting the feed horn to the correct.
This is a C-band only horn. It has a servo motor on the back. It controls the probe inside to match the polarization of the satellite. And when you install this in the dish, you install it at about a 45-degree angle, and then the probe will go to horizontal and vertical. And when the satellite dish is properly tracked, you will find that when you're looking at vertical polarization, the little probe inside will be exactly parallel to the polar axis of the dish. And when you're looking at horizontal signals, it will be across the axis of the dish. There are other combinations of feeds that you will want. Of course, circular and linear combined. This is what we call a co-rotor, and it has in it a dielectric plate that makes it possible for you to receive vertical, horizontal, left-hand circular, and right-hand circular, all under the control of the satellite receiver. Also in the middle of this one, this is called a co-rotor, it has a 12 gigahertz feed, a K-band feed. I've seen many feeds, particularly on tripods or quadrupods, where the feed is squinted off, looking not at the center. If it doesn't look at the center, the main beam will be asymmetrical, and the side lobes on one side will be very high and they'll be very low on the other. So it's important in this initial installation to get that precision. Make it look straight at the center. And when you do that, spend a little time to move the feed in and out to get the best focal point.
The polar mount enables the reflector's direction of focus to sweep across the entire satellite arc by means of a force produced by a single motor called the actuator. But to make this work, 4 separate adjustments have to be made with a high degree of precision. First and foremost, the mount's supporting structure has to be perfectly plumb. Moreover, the main axis of the mount, this part right here, has to be perfectly aligned with the sight's true north-south line. This is determined by using a correction factor to compensate for the amount of magnetic deviation that is encountered at the site. The third step is to set this axis to an angle that corresponds with the site's local latitude. The angle of the main axis is called the inclination, with straight up being 0 degrees and the local horizon being 90 degrees. So always remember that you have to tilt the antenna down until you reach the angle required for your local latitude. Some charts may give this angle as the elevation, which is the complement of the inclination. You can subtract the elevation angle from 90 degrees to get the correct inclination angle. Last but not least is the mount's declination setting, which tilts the antenna downward in the direction of the local horizon. On this particular mount, the declination setting is made by adjusting these 2 bolts right here. Readily available charts and computer programs can supply the specific mount angles that will be required at the site's local latitude. Here in southeastern Ohio, the main axis of the mount has to be set to an angle of about 39.5 degrees. And the declination adjustment adds about 5.5 degrees to that. Even after you've made all of the adjustments correctly, it won't be time yet to snug down all the bolts. That's because of the accuracy limitations of the tools in use. You may have to make some fine-tuning adjustments later on to get everything just right. But once you do have all of these adjustments correctly set, the antenna will track the entire satellite arc with geometric perfection. Installing a two-way broadband terminal requires the same steps to be followed as is the case when installing TV receive-only systems. Adjustments in azimuth, elevation, antenna skew, and feed horn polarization must be correctly made in order to acquire and peak the signals coming from and going to the desired satellite. We can use this chart to find out the correct skew angle for the back of the antenna for the site's latitude and longitude. Here in the center of the U.S., the skew angle is only 88 degrees. It's not that much of an adjustment in order to set the dish. With an oval-shaped dish, it is important that the reflector tilts to the right or left of the mount's main axis to account for the degrees of difference between local longitude and the longitude of the satellite. When an oval-shaped dish is mounted onto the polar mount, this adjustment happens automatically as the antenna moves from one satellite to the next. But with an as-L mount, the skew angle has to be set manually to compensate for the difference between local longitude and the longitude of the desired satellite. In other parts of the country, the skew angle is likely to be great. But here in the central part of the USA, a slight adjustment from 90 to 88 is all that's required. One major difference with a two-way satellite system has to do with the feed, which is designed to illuminate the unique shape of the entire antenna, an oval. Other differences are encountered when connecting the two-way broadband terminal's indoor unit to a PC.